4.1 notes tectonic plates. The layer of Earth we live in is called the lithosphere, and it's broken up in pieces called tectonic plates. Objective: describe geological changes and events that occurred at plate bounding. There are three plane boundary types: convergent, divergent, and transform. And what events or landforms can they produce? And how earthquakes occur while stress overcomes a locked or stuck fault, which ultimately released a lot of energy. Explain how environmental concepts and processes represented visually relate to broader environmental issues. We have Earth's structure and layers. So we have the core, which is a dense mass of soil, nickel, iron, and radioactive elements that release massive amounts of heat. Then we have mantle, liquid layer of magma surrounding core, which keeps liquefied by heat from the core. Then we have the asthenosphere, solid and flexible out layer of mantle beneath lithosphere. Thin and brittle layer of rock floating on top mantle. And then we have the crust, buried out layer of lithosphere, Earth's surface. Now then we have a diagram of the crust, mantle, liquid outer core, and solid inner core. Here it says that heat released from Earth's inner core turns to the mantle into magma, and hot magma drives the movement of the lithosphere plates above it, which is the basis of tectonic plate activity. Now we have here the cause for tectonic plate activity, and we have a diagram of the mantle and the lithosphere, and solid upper mantle and asthenosphere. Moving on, we have plate boundaries. So we have three types of plate boundaries. We have convergent plate boundary. Plates move towards each other and leads to subduction, which is one plate being forced beneath another, and forms mountains, islands, earthquakes, and volcanoes. Then we have divergent plate boundary. Plates move away from each other. We have rising magma plume from mantle forces plates apart and forms mid-oceanic ridges, volcanoes, seafloor spreading, and rift valleys. Then we have transform fault plate boundary. Plates slide past each other in opposite directions and forms earthquakes. Then we have a visual of convection cycles, which is the divergent, and here it shows us a hot spot, which is a section where magma rises up into the surface. Magma heated by core rises to lithosphere, and rising magma cools and expands, forcing oceanic plates apart. It creates mid-oceanic ridges, volcanoes, spreading zones, and seafloor. Magma cools and solidifies into new lithosphere, and spreading magma forces oceanic plate into subduction zone. And then we have sinking oceanic plate melts back into magma. Also forces magma up, creating coastal mountains and volcanoes. Moving on, we have the convergent boundary, which is the subduction zone. And we have three different ones, which is the oceanic and oceanic, oceanic continental, and continental continental. So we first have oceanic. One plate subducts underneath another and forces magma up into lithosphere surface, forming mid-oceanic volcanoes, and it forms island arcs. Then in oceanic continental, dense oceanic plate subducts beneath continent, and this plate melts back into magma. This forces magma up and causes coastal mountains and like the Andes and volcanoes on land, trenches and tsunamis. Then we have the continental, which is one plate subducts underneath another and forcing surface crust upwards, which creates mountains. Then we have transform fault boundary, which is plates slide past each other in opposite directions, and which creates a fault, which ultimately creates earthquakes. So here we have a diagram of the focus, which is the log, which makes the fault in the epicenter, and then creates the shockwaves from there. And that's what we know as earthquake. And then we have a tectonic map, which shows us the ring of fire, which are the volcanoes all around Pacific plate, and the transform faults, which are likely locations for earthquakes to happen.